Good afternoon, everyone. We'll be starting class in 1 to 2 minutes time. Alright, good afternoon, everyone. And today's class is going to be based on object-oriented programming. And in particular, we're going to be looking at this concept in the C++ programming language. What we're going to see today is that the basis of the material in today's lecture is what's going to be forming what we're going to be using throughout the entire course itself regarding how do we actually implement our software projects and how do we go about coding any particular algorithms or answering any particular interview questions. Because when you do go for a programming interview, it's going to be required of you that you're going to have to be thinking along the lines of object-oriented programming or something similar in that nature, depending on the type of interview. So let's get started. Our outline for today is that we're going to be starting with class definitions and objects, and then we'll move on to what we refer to as member functions or methods, and then we'll go on to data members. In data members, there are going to be two concepts that we're going to know as accessors and mutators, as well as constructors and destructors. We'll then move on to further concepts known as inheritance and polymorphism, and then how do we separate our code into multiple different files to make it a lot more organized and a lot neater and easier to manage. It also helps us that in the event that we are working in a team, not everyone is going to be working on the same file. So everyone can write their own code in their own individual files, and then they can come together at the end to compile everything into one huge project. We also look at how we separate what we refer to as the interface from the implementation. And finally, we'll talk about the last concept here, which is going to be overloaded functions, which is going to be a very interesting concept as to how you can use the same function in multiple different ways. So your typical C++ program structure, as you have seen from the ECNG 1009, consists of a main function so far, and then some individual functions. However, for ECNG 2007, we're going to be looking at that we're going to have that same main function, but also we're going to have one or more classes that's going to be above the main function or in separate files. And these classes are going to contain what we refer to as data members and member functions. Now, data members can be any sort of variables that you've been encountered with so far, like your integers, your characters, your doubles, your floats, and so forth. Your strings in particular as well. And your member functions are basically any type of function that you've already created in the past. But now we're going to see how they are going to be localized towards this classes concept that we're being introduced towards. Now, in defining a class, basically a class is going to have a collection of these member functions and data members within itself. And in C++, you can actually just use the keyword class and then open and close your parentheses brackets to say, okay, this is the body of our class. And we put all our member functions and data members inside the body of our class. Because we're using the keyword class here, that means we're going to have to name our class. So we're going to have to give it a class name entirely, and this is going to be our reference towards that particular class that we're going to be creating. There are also one other thing that we need to pay attention to when we're creating the class, and that's going to be access specifiers. Now there are three types of access specifiers, but there's only one listed here on the slide, which is public. So public means that any member function or data member can be accessed by any other functions outside of the class. There are two other access specifiers, and I'm going to write them here on the slide for you. So you actually can do a quick lookup afterwards to see what they mean. There is protected, and there is private. And basically what these access specifiers basically do is it controls how do other functions outside of your class or within your class can interact with the data members and member functions within your class. So you can take like a really smart guess here, and you can see that the private access specifier here means that if it's private, it's only going to be accessible within its own class. What I want you guys to do here is actually search up how does the access specifier protected work with respect to classes. And you're going to see that's going to be a mixture of public and private, but it's not going to be how you expect it to be. So that's one thing I want you guys to actually look up and see how that works. In general practice, however, the two access specifiers that you'll be using most of the time are going to be public and private. It's going to be some very rare cases where you're going to be using the protected access specifier. Now here we have a code example here in C++ as to how we can actually go about creating our first class. And yes, I know it might be a while that you've seen some C++ code, a couple of months maybe, but we're going to get back into it throughout this session, and we're going to see how do we go about implementing our classes and how we actually start calling them in our main function and make reference to them and so forth. So general C++ file is that we have our includes, we have our using statements to say, okay, these are the functions from the IOStream library that we want to use and so forth. But the highlighted parts here, it's what's going to be important to regards how do we implement our classes. So we have our class keyword here, and we're going to give our class a name here of gradebook. And then we say, okay, we want our access specifier right after we open the body of the class. And we can see here we have the closing parenthesis bracket to indicate the closing part of the body of the class. So the first thing that we put inside the body of the class is going to be our access specifier. So we're going to say public. If we do not put this access specifier, all the member functions and the data members within the class are automatically treated as private by default. So get into the habit of putting this access specifier here as a matter of good practice. So that way you won't run into problems later on when you're using your class. Once if you put the public access specifier here, we then go about creating our member function, or what we refer to as a method, within our class. So the method that we have here inside our class is going to be display message, and it just acts like any general function, but now it's just encapsulated inside the class itself. And we're just going to have a cout statement saying welcome to the gradebook and close it off. And finally, we can see here that at the closing parenthesis brackets, meaning that where the body of our class statement ends, we have a semicolon indicating that's going to be the end of our definition of the class. So we have one question here in the chat saying, is there a specific style guide that we'll be using? There are basically two different styles that you can use when you're implementing classes. I'm going to show you one particular style, and like when we get to the tutorial sessions, when we start doing live interactive coding and so forth, I'll show you the other style as well, and then you can choose like, okay, which style is a little more comfortable to you. There is no drawback to using either one of the styles. It's basically a personal preference as to how you want to go about coding yourself. And there's no further drawback, like if you're working in a team, let's say if you use one style versus the other, it's not going to have any effect on how the code is going to compile or how it's going to operate and so forth. It's still going to compile correctly, it's still going to operate correctly. If there are errors, it's still going to generate the same syntax errors if you're using one style or the other. So it basically comes down to a matter of preference as to which style you just want. But the style I'm showing you here is more of like the traditional style. and it's the style that a lot of people tend to use, and it's easier to debug and see errors. But there's another style, like I said, when I reach to the live tutorial sessions, I'll show you that style, and if you're more comfortable using that style, that's perfectly fine. Alright, so moving along, once we finish define our class gradebook here, we can see here in our main function, because we have class gradebook, this comes like we defined our own data type in a sense, because we can actually call this as gradebook here in our main function. So the class gradebook here comes like, okay, this is our own definition for our own data type. And we can call that as gradebook here, and we can give that a name being my gradebook. So this gradebook here, being our class, just to reiterate, comes like if it is our own data type. And because it is our own data type, we're going to have to treat this here as my gradebook, a variable of data type gradebook. Because this here is going to be treated as a variable of data type gradebook, in classes we refer to this as an object. And once you have an object of type gradebook, that means to access any of the member functions or data members within our object, we use the dot operator after the object name in order to access these functions here. So we have my gradebook dot display message. That gives a reference to the display message function that we have here inside our gradebook. And typically with any main function, we have a return 0 statement in case that's the end, and so on. So the slide here is annotated to basically give you the short rundown of what I just now explained, and the quick reference for trying to understand how does this code operate. This slide also indicates the explanation that I just gave you in regards to why this variable name is treated as an object, and why the gradebook here is treated as our own personal variable, our own personal data type in this sense. Now, one thing to note here is that when we create our own object here of class data type gradebook, this variable here is allocated onto what we refer to as the memory stack. And the memory stack is a concept we'll get to on in later lectures. But for now, the short explanation for how the memory stack operates is that anything that you create or destroy within your main function, it gets allocated upon this memory stack to say, okay, for our available memory that we have for the program, once we create an object, we allocate that object onto that available memory. And later on, when we see how do we destroy memory, or free memory in this case, you'll see that, okay, it's going to be deallocated from that memory stack and so forth. But we'll get to how the memory stack operates in later lecture. Now, another example here of how we can use member functions or methods with input parameters within our class is, let's say we have the same class gradebook here, and instead of having our display message with no input parameters here, we want to actually put an input parameter here that we might want to use later on. So we can actually include a string library, and we can say like use an std string and so forth. And because we have this input variable here, we can actually use this input variable within our display message function, just like any other general function that we've been exposed to. The key difference is that when we actually watch how do we use it in our main function, we can have string name, of course. We can create our gradebook object here. And then we can say, okay, we want to output please enter the course name, and we can use the getLine function from the string library to grab the course name from the console window. And then we can pass this string here that grabbed the console input into our display message method that is encapsulated in our myGradebook object. And once we run this code here, we can see here that if we enter this and we say, okay, this here is going to be our input, our output that's going to be generated is this message here, seeing that our string from the input line is going to be outputted here on the console screen as required. So passing input arguments to any of the methods within our classes operates the same way like if you're doing it with traditional functions and so on. There's no key difference. Basically, it's just going to be encapsulated within the class itself. Now, some useful tidbits here is that for user input from the console line, it comes very handy if you start using string inputs instead to store the user input. So when you use a string input, this is a very convenient way for us to actually store any character inputs from the keyboard itself. And because it's a string, it's not treated as a character array. Now, just to recap a little bit, a character array, if you're defining this in C++, it's going to be like char, and then you have your array brackets here, and then you say, okay, let's give it a name, test. And then you could be like test1, or test0 because I already started 0, equals to h, and then test1 equals to I, and so forth, right? And that's pretty annoying to go about doing that. Whereas if you have the string, and you could have like string test, you can just say that equal to I in double quotation marks, and you can just define your characters immediately. So it's a lot more convenient to be using the string library in this case. The other thing to note is that instead of using cin that we just now saw in the previous slides, we use the getLine function instead. And the getLine function has the advantage over the cin function because when you use cin, and if you have spaces in your input, once the space is encountered with cin, it's just going to truncate your input at that point. So like for instance, let's say if we had a string like hi, this is input, and let's say if you're using cin here, what happens is that cin will just see the h and I and then the comma, and then everything here, that's just going to be discarded. So when you output, so that's when you go to cout, all you're going to get is just hi, comma. That's all you're going to get when you use cin. Because cin does not see spaces in your input. So get into the habit of using the getLine function, so that way once you use getLine, you get all of the characters that you'll have on your input. So all the spaces and so forth, getLine will capture it for you and will display it as required. Alright, so I know that was a little bit to take in here at this point. Are there any particular questions regarding the material at this point in time? Yeah, I can repeat that. Alright, so when you're using cin here, right? So I'm going to erase the ink on the slide here, and I'm going to repeat what I just now did. So let's say we had an input variable here. So let's say string input. Alright? And let's say if we use cin here, and we wanted to put input here. I'm probably using the wrong angular brackets. No, I'm using the right angular brackets. Right? So let's say if we're using it like that, right? And let's say in our input, when we type in our string that we want to put in, we want to put like I, comma, this is input. When you use the cin function, all you're going to get is this part here. Everything else here, from the space go onwards, that's going to be discarded. So when you cout input, oops. Once you see out, excuse me, I'm getting a little bit tied up here. So when you see out your inputs, oh man. Okay, just a little bit of technical difficulties. All right, let's go. All right, so let's say once you see out your input here, all you're going to get is hi. That's all you're going to get. I'm just going to rewrite this here. String input. In input. Inputs. So this is all you're going to get. And this part here, that's discarded. So that's what happens when you use cin. Any space in your inputs, it's going to truncate at that point when you use cin. So anything before the space you will get, anything after the space is just going to discard it entirely. And that's why you should not be using cin for any character inputs from your keyboard. When you use getLine, however, getLine will get the entire character input. So it will get entirely hi, this is input, with all the spaces and so forth. So make it a habit to use the getLine function instead of the cin function to avoid this error. And no, that's because we define the string as hi, this is input. So this is like our input string here is this entire string. But once you're using cin does not see any spaces. So there's like hi, comma, and then we have a space here. Once we see that space, it's just going to take everything before the space. Everything after the space, it doesn't see it at all. It's just going to discard it entirely. So once we output that input string, all we're just going to get is just hi, comma. And that's just how cin works. It does not see spaces. So if you do have a string with spaces, and it's generally just for better practice, use the getLine function. It will get all the spaces in the string no matter what. Alright, nice. Any further questions? So yes, strings also are treated as character arrays, but they're also like a specialized character array, so you can get away doing more stuff with them. There's a lot more functionality using a string than a character array. Because let's say if we did have to use a character array and we had to output it to the screen, that means we're going to have to use a for loop to process each and every character to output it. The cout function, it doesn't play nice with character arrays. So it's a lot more easier and more convenient to use strings than character arrays. Now, I mean, there are some very rare cases where you will have to use character arrays, and that's going to come down later on when you're doing something like embedded programming, or you're dealing with specialized microprocessors, where the memory requirements are very strict. But when you do encounter that, you just have to use a for loop and output each character in the array one by one. And I guess I can explain that in the interactive sessions and physically show you what's going to be the difference between using the character array and the string in that particular case. So I'm going to write that in the slide, so I know to get it in the live demonstration sessions and tutorials. So different outputs for character array and string tutorial. Right, so I'll know to discuss that at that point in time and show you physically what's going to be the difference and how you actually implement it, and why strings are going to be better than the characters. Right, doesn't look like we have any further questions, so let's move on. I mean, if there are any other questions, feel free to interrupt and ask in the chat, and I'll get to them once I'm finished explaining whatever I'm talking about on that particular slide. All right. Now, data members regards to our class is going to be defined within the body of our class. And we just saw an example of this where we had our display message function being encapsulated in the class gradebook. We also saw an example of the public access specifier. And like I said, there are also two other access specifiers, which is going to be protected and private. Once we create an object of that type class in our main function, that object of that type class will have access to all the data members and all the member functions that were defined in that class. And so long as the object exists in memory, meaning that once we create the object, that access to all those data members and the member functions will exist throughout the lifetime of that object until it is deleted from memory. Now, it is possible to have multiple objects with different variable names of the same type of class, just like how you can have multiple integers, multiple doubles, multiple floats, and so forth. Each object is going to have its own copy of the data members and the member functions within that class. So that way they don't coincide with one another. So it's like, just to simplify what I'm talking about here, if we had two integers, so let's say int a and then int b, and we say a here stores a value of 1, and int b here stores a value of 2. We know a here has its own value of 1 and b has its own value of 2, and depending on which one we call, we get the values. Just to add a little bit of confusion here, let's say int b here also had a value of 1, but we know that this value of 1, that is in a, only belongs to a, and this value of 1 here, that is in b, only belongs to b. So it's the same concept once you have multiple objects of the same class type. Yeah, basically it's multiple modeled cars using the same car class. That's a good analogy to it. Thank you for that. Now, to answer the question about the access specifier private, that means once you're using the private access specifier, you only have access to the member functions and data members within that class only. So if you try to access it outside of the class, it's not going to work. And when I start doing a tutorial session on this in particular, you're going to see why this is particularly important. And that means that if you have any other functions outside of the class, it cannot get access to your functions within the class or any data members within the class itself once you're using that private access specifier. Now, this may be very important to prevent any other functions interfering with the operations of your class or objects derived from that class. And it also prevents any mishaps that you may have made with regards to how your data members and member functions within that class should operate without any external interference. So that's what we refer to here as information hiding. Basically, you're having a more controlled way that only certain functions can access your data members and your member functions within that particular class. Anything that is outside of that class cannot access it once you're using the access specifier private. So in this particular case of our code example here, if we watch our class gradebook, and we can still see that we have the public access specifier, and we have our functions here being set course name and get course name. These functions here are going to be accessing this variable here named course name. So set course name here is going to assign a string variable to our class variable here that's going to be named course name, and get course name here will return what is stored in our class variable here named course name. If you go to the next slide, you can see here that the string course name is going to be under the private access specifier. So meaning that only functions, being the member functions within this class here, can access the string variable here named course name. As we can see here for our display message has access to course name here by using the get course name function itself. Now similarly, we can say, okay, instead of using get course name, we can just put course name because it's within the class. But we just use the get course name function here just for easier access and controlled access. Now, in our main function, when we have string name, of course, here just being an input placeholder here for our input string, and we create our myGradebook object of the gradebook class type. We can grab the course name here by saying, okay, our initial course name is myGradebook.getCourseName, and that's because we're in the main function. So the myGradebook object here has access to getCourseName. Go back one slide. And this getCourseName here is a public function within our class. This getCourseName, because it's within our class here, has access to the private member variable that we just now have here, that is named courseName. So when we actually use this here in our main function, we are able to obtain whatever is stored in course name here, even though it has access specifier private. But we're using the get course name function here to get access to this private member variable. Now let's say, for instance, I'm just going to extrapolate here a little bit, that somewhere within our code here, we try to do my gradebook and we put dot course name, and let's say we try to get access to course name here using the my gradebook object. This is not going to work because first of all, we're in our main function, we're not within our class, and course name here has private access specifier. Yes, if we change public to private, the main function cannot use it. That's basically what's going to happen. It wouldn't be able to use it at all, because it's only going to be localized towards our class. So if we try to access course name here because it's private, it's not going to get access to it, because it means to say, okay, it's only within the class and nothing else can access it. If it was public, on the other hand, we can actually see what's stored in course name. And just to go along with the code here, let's say if we actually input the name of the course from our keyboard, we can set that into our course name variable here by using the set function, being set course name, and just using name of course here being our input placeholder string as our input variable in our function. So let's backtrack to how set course name here works. Set course name grabs an input string, it could be any input string that you wish to pass, and it stores whatever is in this input string here into our private memory variable course name. So the return course name here, remember this is within the class itself. So once it's within the class, it has access to it. The return course name here, all it just does is just basically, for lack of a better way of saying it, it just accesses whatever is inside the course name private member variable, and it just puts it back out onto our screen if we have an output cout function. So once we set the course name here inside it, and we go about doing it, once we call display message also has access to it. So display message will actually show welcome to the gradebook for CS 101 Introduction to C++. Yeah, so I know I'm getting a good bit of questions. Any questions you need to ask, just ask them straight in the chat, and I'll address them immediately. Yes, the mygradebook.getCourseName will return the course name. And the reason why it returns the course name is because the get course name here is part of the class. Return course name here, because course name is a private access specifier, it's still within the class here. So any functions within the class here can access these private member variables. But anything outside of the class cannot access it. So that's why you need to use those get functions and those set functions. Oh, line 58 is just to show that you can use other functions to access that course name variable itself. So if we go back to the display message function here, you can see that welcome to the gradebook for, and we have get course name, and get course name will just return the course name as it is, and it will just output the course name for. It's similar to like if we just call, instead of using get course name here, we can just put like, okay, we just want course name to output here as well. But some compilers actually will complain with you that you're not supposed to do this because of how the compilers are set up. So the safer way to go about doing this is using the set function and the get function. Some compilers just won't complain and be like, okay, it's part of the class, so you can access it within the class. All right. Any further questions at this point? Alright, doesn't look like we have any further questions, so we'll move along. I mean, if we have any further questions, like I said, feel free to ask them in the chat. Now, in general practice, when you're using classes, a good rule of thumb is that you should always set all your data members as private and your member functions as public. And if you need to access any private data members, you need to have what we refer to as an accessor, which is our get function, like we just now saw as get course name, and our mutator, which is going to be our set functions, which is set course name. So an accessor will return the course name or return the data member, and a mutator will set the course name or set our data member. So just to annotate here a little bit. So the accessor, which is get, was get course name, and that returns the member variables that we needed. The mutator was set. So this was set course name. And because it was a mutator, meaning that we had to set it, that means we needed an input variable for our function. So we could have been like string input. And that sets our course name for us as required. So the accessor will return the private data member variables. The mutator would set the set values, to our private data member variable. And like I said a few slides before, this is important to make sure that you have controlled information access within your programming stuff. So having multiple functions trying to set these data variables and overwriting them and so forth. You have this control access, meaning that, okay, only this function can set this, and only this function can actually return this, and so forth. The accessors and mutators, getters, and setters. Now we're going to move on to a few specialized functions within the basically is what's responsible for allocating and memory and creating your objects of that class type in the main function. You can create your own constructor within your class, but there are particular rules as to how you go about creating these. So your constructor here must have the same name as the class itself. And there's no return types with it. So there's no void, there's no int, there's no long, there's no double, none of that. It is possible to have more than one constructor with different input parameter lists. And we might see an example of that later on in the tutorial. But this is actually the concept of what we refer to as overloaded functions, which is going to be introduced at the end of this lecture. If you do not define a constructor, the compiler automatically provides one for you. And the constructor is called automatically once you create an object of that particular class type. It is also possible to create memory by using a keyword named new within C++. And we'll also see how we go about using this new operator once we get to our tutorial sessions and so forth. The destructor is the opposite of the constructor. The destructor is responsible for freeing up memory or deleting memory after you've completed using the object in your program. It has the same rules as a constructor. There's no return type and so forth. The only difference is that it's going to have this tilde sign before its name. And yes, it does have the same name of the class. It does not accept any parameters. It doesn't return any results. It's just there to exist to free up memory. If you do not define your destructor, the compiler will also automatically provide one for you. The other way to use like destructors in particular is known as the delete operator in C++. Like I said, we'll get to that in a tutorial session as to how we actually go about doing using the new and delete operator. For C++, we will not be using malloc. And the short explanation for this is that malloc was originally designed for C. Because C at the point in time did not have a nice fancy way to go about doing memory allocation. So they needed their own memory allocation function, which is short for malloc. So the M here is the memory, the alloc is the allocation part. Eventually, when C++ came along, they replaced malloc with the new and delete operators and the constructors and destructors and so forth, because they realized the malloc function, it does not play nice when it's allocated and deallocated memory. It wastes a lot of memory. So they realized they needed to find a more optimized way to go about doing it. So that's why the new and delete operators came into play, and the constructors and the destructors also came into play as well, because they realized malloc actually was wasting a lot of memory. So for this course, no, we will not be using malloc. We'll be using the successors to malloc, which is going to be the constructors, destructors, new and delete operators. Now, in other programming languages, you're also going to be exposed to constructors and destructors in some particular form. I'm just illustrating one for you guys if you're using the Java programming language, because when you're going about doing your software project for this course, you are not going to be restricted to C++. You are free to use any programming language that you please to achieve your objective. So the concepts that you're learning in this lecture also transfer over to other programming languages as well. Yes, the syntax is going to be different because obviously it's a different programming language, but the concept remains the same. So let's say, for instance, if for some reason you have to use Java to implement your software project this semester, the constructors that you learned here in C++, it's the same way you go about implementing them and using them in Java. However, Java does not have a destructor. Java has an automatic deletion of memory and their own concepts for how they go about treating memory. So in our example here, within our gradebook class, we can have our constructor here being the same name as our gradebook class, and we can have an input variable here for our constructor, and we can use our setter here to allocate something once we create our object in main. So we don't absolutely have to have an input variable here or to have any instructions in the constructor. We can actually leave this blank. We don't even have to put a constructor. And like I said, by default, the compiler will provide one for you. But if you wish to define your own constructor, this is a nice example of how you can go about doing this. Once the object is created, how you can allocate something to the object immediately upon creation. So just reiterating here, remember our course name here was a private data member variable, and we don't have a destructor defined here in our class. We just only have a constructor. So by default, our compiler will provide a destructor for us. Once we are finished using our object in our main function, the destructor here is just going to free this memory allocated to course name itself. So if we create two objects here of class type gradebook, and we say it's gradebook 1 and gradebook 2, we can actually allocate memory to that private data member variable here, name course name. Upon creation of gradebook 1 and gradebook 2, I put in the string here as our input for the brackets. So once gradebook 1 here is created and gradebook 2 here is created, and I'm just going to give the example here with respect to gradebook 1. Once we have gradebook 1 here being created in our main function, creation of gradebook 1 here automatically calls our constructor here for gradebook class data type. And the gradebook constructor here, it operates just like any other function, but it's also responsible for allocating the memory for that object that we created in main. So it can also do our own particular instructions upon creation of that object. So our instructions here for our constructor is that, okay, we want an input string here, and we want to set the course name here using our input string, and the set course name function allocates that input string here to a private data member variable within our class course name. So those sequence of instructions is what happens when you create the first gradebook 1 object here. You want to store this input string here in between the brackets into a private data member variable in our class. The same operations happen when you create gradebook 2. And instead of doing all those previous instructions that we saw in previous slides to go over setting it and then getting it, we can now just have gradebook1.getCourseName and gradebook2.getCourseName. And we can see that our input strings here that was stored upon creation of the gradebook 1 and gradebook 2 objects is now stored and can be retrieved using our get functions for gradebook 1 and gradebook 2. Right, any particular questions to clear up any misconceptions here? You're free to use C++ or any programming language you wish for the software project. You are not restricted to C++. Alright. Okay, so any other particular questions here? Let's go on. Now, in reusing our implementation here, that means that it's possible us to keep on reusing our class using different objects. The relationship that we need to observe here is that there's going to be something like an is a or it has a relationship, and an is like a or it has like or is somewhat like a relationship. So the reason why we have access to all those particular member functions and data members is because of a concept known as inheritance. And that is because when we create that object of that particular class type, it inherits all those member functions and all those data members that were created within the class for that particular object. Now, it is possible in inheritance is that we can take a class here and clone it and make any additions or modifications to that clone. So we can have a default shape class here, and then later on we can actually have a circle, a square, and triangle class that inherits from our shape class. And what that means is that the shape class that has the draw, erase, move, get color, and set color member functions that we saw here, or methods. Circle because it inherits from shape, square because it inherits from shape, and triangle because it also inherits from shape, has access to these draw, erase functions as well as the move, the get color, and the set color function. However, because these inherited classes here are also unique in nature, it is possible for these inherited classes to have their own individual function. So whereas triangle here still has access to all these shape functions, so like this, 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 flip horizontal and flip vertical here, these only belong to the triangle class. So this means that square here and circle here will not have access to this flip horizontal and flip vertical because it's only localized to triangle. It does not exist in square, it does not exist in circle, it does not exist in shape, which they are getting the original. To give you an idea of how we go about doing this, we can have our original class shape here, being where we have all our public functions, draw, erase, move, get color, and set color. And then we can have class triangle, and we use the corner operator in C++ to say, okay, we are inheriting from our shape class. Now, in inheritance, you need to specify an access modifier here. And typically, when you're inheriting, you use the public access modifier. So this here will actually give you access to all of shape's member functions, and if we had any data members, it will also give us access to them. In addition, even though we inherit from shape, triangle can have its own individual functions, and these functions here are defined within the triangle class. That's going to be flip vertical, flip horizontal. All right. So before I move on to the next slide, are there any particular questions on the concept of inheritance? Yep, it's the same concept as base as derive. So base and derive here, back here. Base and derive is basically saying the base class is what we are inheriting from, and our derived class is what we inherit to. So our base class here is like basically saying this is the first class that we start with. And then the derived classes will be inheriting from our base class here. So just to annotate this for you. This is our base class, and these here are derived classes. There is a situation where you may end up using private as the access modifier, but it's so rare that I hardly ever use it. Most of the time you end up using a public access modifier for inheritance. Okay, let's move along. So back here. So in using inheritance, there's a key difference between an is a and an is like a relation. So our thermostat here, if we have this, it can be like, okay, our thermostat has a lower temperature function. And we can have our cooling system here. Yes, I know cooling is spelled wrong. And our cooling system here can have its own cool function. So this thermostat here can basically be controlling our cooling system. Now, if we watch our cooling system here, and we see our air conditioner, which has cool, the cooling system here is basically has an is a relationship with our air conditioner, because it's basically the same functionality throughout the entire thing. However, when we observe our heat pump here, our heat pump also has cool and heat. Because of this difference, our heat pump here is going to have an is like a relationship to our cooling system we had to be. So just reiterating this, when you're doing inheritance between your base and derived classes, if your base class is exactly the same as your derived class, this is going to be an is a relationship. If your base class is not exactly the same as your derived class, but it still has some of its same functionality, this is going to be an is like a relationship. Any particular questions on this? Yeah, sure, I can repeat. So, when you're doing inheritance between base and derived classes, if your base class is the same as your derived class, this is going to be an is a relationship. As we can see here, our cooling system has the same functionality as our air conditioning system. If your base class is not exactly the same as the derived class, meaning that they do share similarities, but the derived class has additional functions. This is going to be an is-like a relation. Yes, it is possible for you to inherit from multiple base classes in C. So the heat pump here can inherit from the cooling system, and it can also inherit from a heating system if we had a heating system outside as well. So like it's like, just to extrapolate a little bit, you can have a heat system here, and we could have heat, and we could also inherit that inside here as well. So that comes out if we're doing multiple inheritance. Typically we try not to do that, but in some cases you may have to do it, and that's perfectly fine if you have to do it. But multiple inheritance, it is possible. So to answer the question, why would we ever use an is-a class as opposed to the base class? There are some cases where you may want to write a class, but you cannot write its functionality immediately. And they still want to protect that class, meaning that they need to follow this particular syntax or this particular structure. So that's where you will end up using an is-a relationship instead. So you mean to say, okay, the class must follow this particular structure and must have these particular functions of this particular order. These functions here are going to be public, and these data member variables saying are required to be private. Even though I'm not writing the functionality at this point in time, I'm going to actually have the structure here, but you are free to inherit it afterwards and continue its functionality instead of doing edits upon it. Because if someone goes inheriting the original class, if someone goes editing the original class, you don't know what edits they're going to make, and that's going to make your changes harder to track. And then because they edit that original class, you don't know how it was to begin with. So that's when you end up using an is-a relationship in particular. I believe it will look something like that, but let me check that back for you. I'll write on the slide here so I can make sure I can check it and I can post up the answer for you. Check multiple inheritance. Yes, it would look something like this here if you're drawing flowcharts for classes. And in particular, if you're looking for the terminology for what that's going to be, it's referred to as an entity relationship diagram. An entity relationship diagram looks something like what I have here on the slide. It is possible for certain compilers, after you write your code, to automatically generate this entity relationship diagram for you. You actually don't have to draw it. Right. Any further questions? Right. Now there's another concept beside inheritance known as polymorphism. And polymorphism is basically a way for you to extend your program functionality in different ways. So even though that we have our goose and penguin classes here, inheriting from a bird class, and we can have a bird controller here being relocate, and we have the move here. Once we call this move, it comes like if we're trying to call the relocate to administer the move command for bird or goose and penguin. Now what polymorphism does here is that, let's say for instance, if we had some function here defined in shape, and we don't use it in circle, square, or triangle, it's still possible for us to go about using it in circle, square, and triangle in some sort of fashion. It's also possible for us to use an object of type shape here within our circle, square, and triangle accordingly. Wait, no, I'm saying that wrong side. My mistake. It's also possible for the shape class here to use objects of circle, square, and triangle appropriately because of that inheritance need. So repeating that for you guys. Polymorphism is such that because of the inheritance relationship here, such that circle, shape, square, and triangle are inherited from shape, it is possible for any functions that you have in shape here to operate upon objects of type circle, square, and triangle using the shape function. Also referred to as the term here as upcasting. So whereas inheritance works downwards because of the relationship, polymorphism operates in upwards instead. So just to illustrate, shape here, that's like a class data type. And circle, square, and triangle, because they inherit from these. So this is like the base class data type. And these here are what we refer to as the derived class data types. And because of that inheritance nature, sharing that relationship between the base class and the derived classes, it's possible for us to use any object that is circle, square, or triangle within our shape function because of the inheritance relationship. That concept is what we refer to as polymorphism or upcasting. Any particular questions on this? Any derived object from the base because of the inheritance nature. So because shape, circle, square, and triangle is basically a shape, that because of that is a relationship, that means that, or that is like a relationship, that means we can use any object of circle, square, and triangle here for our shape functions accordingly. Yep, it happens inside the shape class. So let's say if we had this do stuff function here and accepts an input class type here of type shape, and it's going to do serase, sdraw, and whatnot. We have circle, triangle, and line here being individual objects. Because of this relationship that it has here, because circle, square, and triangle is a shape or is like a shape, because of that relationship, because of inheritance, that means we can pass circle C here as a shape data type for do stuff, the triangle T here as a shape data type here for do stuff, and the line data type here as L as a shape as well, and so forth. And that exists because of the is a or is like a relationship due to the inheritance. So this concept where you're using these derived class data types as our base class data type instead for a particular function, that is what we refer to as polymorphism or upcasting. All right. Any further questions? Okay, it doesn't look like we have any further questions. Long, like I said, feel free to interrupt once if you have any questions. All right. So in separating your code into different files, we're going to be using C++ files and another file that we refer to as a header file. So your source code, being like your main functions and whatnot and so forth, or any other functions that you want to create that's not going to be a class, we're going to be storing these in C++ files with extension.cpp. In some cases, you might want to put the class implementations inside there as well, or in the test programs, that's perfectly fine, not a problem. Your header files are going to be for what we refer to as code definition. Like, how do you define your class? How do you define your functions that you're going to be using, and so forth? And we're going to be including these header files to make reference to them, so that way you have access to these functions. A driver file is basically going to be your own separate C++ file. And your driver file can be basically dedicated only towards testing your. This driver file can have its own main function, or you can have this being that, I'll extrapolate here a little bit. Or you can just be like driver function. And once you link your driver file into your entire project, you can just use the driver file as required. So you can have that separate driver file there, but testing your program separate and distinct from your main code, from your main definitions and so forth for your classes and your functions, and that's going to be dedicated only for your testing in your driver file. It's going to make things a lot more manageable, a lot more easier. You don't have to go back and keep on editing your functionality of your code and so forth. You can just use it as is directly when required. So There's also a certain concept that we refer to here as interfacing. And the interfacing is basically what your client may see and how your program is presented towards them. Now, your client doesn't really care much about how your program is implemented. They may not even have knowledge about how code works and so on. All they're going to be caring about is, can this thing operate as expected? So your interface is going to be a little more important, and this also can be a separate file. It can be a separate C++ file, it can be a separate header file, and that's perfectly fine. However, from a programmer's perspective, your interface is going to be your definitions here within your header files. So all the header files that you're going to be creating are going to be treated as your interfaces. And you're going to see an example of what this looks like, and probably on the next slide or in a couple of slides. You can have a better idea of how you go about separating your code and so forth. Your implementation, on the other hand, are going to be all your CPP files, your C++ files, so .cpp extensions. And you can use the binary scope resolution operator, which is going to be a double colon, and this is where I'm going to get to the second way of how you can actually write your classes, to actually go about defining how your classes and how your member functions are supposed to operate and so forth. So in separating the interface from the implementation is such that people don't need to know how exactly everything runs from the client perspective. From the programmer perspective, you just need to know how your class is defined and how you go about writing code for your class. Implementation, on the other hand, is actually how your functions operate. So that's actually going to have all the nitty-gritty and all the instructions for each one of your class member functions and so forth. So this is actually a nice example of an interface. You can see here, this file name here is going to be gradebook.h, meaning that's going to be a header file. And inside gradebook.h, we're only going to define the structure of our class. So you see we have class gradebook, we have the public access specifier, we have our constructor, our setter, getter, our display message, and our private data member variable. And that's all there's going to be inside the header file. Nothing else. Instructions on how each one of those functions are supposed to run. No explicit code. None of that. It's just only going to be how do you want the structure of your class defined. And that's a good example of what an interface looks like. Your implementation, and you can see here this is going to be gradebook.cpp. It's going to be a C++ file, and you're going to have to include your header file in order to get access interface that was defined here previously. Once you have access to the interface here, you can now go about defining how each one of those functions here in the interface in your class is supposed to operate. And this is where the binary resolution scope operator comes into play. So this is the second way how you can go about implementing your classes. So if you wish to do the multiple file approach here that I'm showing you, this is the second way to implement your classes. If you do not wish to do the multiple file technique here that I'm showing you, you can use the first method that we saw at the start of this lecture. So either way is fine. There's no key difference. It's just a matter of strategy and how you wish to go about using it. So because we include gradebook.h here, this include here, basically what it does, it just acts as a placeholder, and it kind of virtually copies all the lines inside this file here and puts it right here so it knows to access it. And then when we have to define how each one of our class member functions here or class methods operate, we're going to be calling this as gradebook, being our class here. And then we have colon, meaning that, okay, we need to access what the function is here. Gradebook here being our constructor, write our function accordingly. Similarly, for set course name, we say void gradebook set course name to access it and to write our instructions for it, and we define it and so forth. And we do the same thing here for get course name and display message. And then we can have our own separate C++ file here in our driver file to actually test our functionality of our gradebook. And inside our driver file here, we can just only include gradebook.h, and we can actually have automatic access to all the functions that we just now had. So this is a nice example of how we can go about separating our code implementation into multiple files and putting it as the interface, implementation, and our driver file. All right. Any particular questions on this separation of files? Yes, this is entirely optional in the software project. It's just a different style of going about separating your files, a different management style of how you may wish to manage your code and so on. Yes, we will be getting practice on these topics. That's the point of the tutorial sessions that we're going to be doing later on throughout the entire course. So once we go through the tutorials and we see how we go about doing these, it's going to make a lot more sense as to how we go about doing it and so forth. The example code here presented on the slide is code that you actually can copy and paste, and you can actually try for yourself in the meantime, see how it actually operates. I'm just giving you the explanation as to how it actually works behind the scenes. Anything in particular that you want me to explain, feel free to ask now so I can give you further explanation and clarification. Right, so the driver file interacts with that implementation file that you just now saw here, in this file here, due to the linkage of the gradebook.h. So gradebook.h, because you have it here, and it's going to be public gradebook string, set course name and whatnot, this being just the definitions, and this has been the implementations. This implementation file here links to gradebook.h. So when you include gradebook.h here in your driver file, it automatically knows where to find these functions as well. It also helps because when you're creating your projects, I'm just going to illustrate this. You normally see like you'll have something like header files, and then you'll have your db.h file here, and then you'll see source files. You'll have driver.cpp and db.cpp. Your project also does the linking for you because it knows these files are located within the project. If you're not using a project, once the file is within the same directory, it also knows to make the link. So that's how it's able to make those references. Right, any further questions? Nice, glad you got it. Yes, GB just CPP is the implementation file. I'm just writing GB because it's short for gradebook.cpp. But remember, implementation files are .cpp, the interface files are .h, and your driver file is also a .cpp file. Right, doesn't look like we have any further questions. Let's move on for the time being. The last concept that we're going to be dealing with today is what we refer to as overloaded function. So an overload function is basically a function that has the same name, but the inputs are going to be different to the function. So we can have do something int A int B, and we can have a do something being the same function that has 3 inputs instead. And then we can have do something that has 2 inputs, but they're going to be 2 different inputs altogether. Instead of int A, int B, we have int A and string B. For each one of these implementations, you're going to be writing their own code for each one. So like for this one, we can have return A plus B. This one we can have return A plus B minus C. And this one we can have the out You want to forgive me if I'm actually drawing the angular brackets the wrong direction. A and then B. So we can have the same function name, but so long as the inputs here are going to be different in some sort of fashion, we can have different instructions for each one of them. And the reason why we call it an overloaded function is that yes, it does have the same name, but depending on what we pass as the inputs here, is going to execute different functionalities altogether. Now this is kind of important, especially for your constructors in your class, because in certain cases you may want your constructor to implement or allocate memory to different private member variables depending on the functionality that you intend to use. So you may have, let's say you have like 2 private data member variables, and let's say for one particular case you only want to use one of the member variables. You can have your constructor be in gradebook int A, and then let's say later on you may want to use both of the private member variables. Then you can have like gradebook int A, int B. So it will know which one to call because of the difference in the input for that particular function. Like I said, this is the concept of overloaded functions here is particularly important for constructors in C++, because this actually helps you allocate memory to different private member variables at any particular point in time. All right. Any particular questions on overloaded functions? function itself looks like how you basically see it on the slide here. So it's going to have the same function name here, and then all that differs is just the input list, so like your input parameters. Alright, well, it doesn't look like we have any further questions. So just to recap what we did for today, is that we introduced the class definition and objects. We also looked at the access specifiers, looked at the syntax for the member functions and the data members. We also looked at specialized functions such as the get and set functions, we know accessors and mutators, and constructors and destructors for allocating and deallocating memory for objects. We also looked at the inheritance and polymorphism concepts. In particular, we saw the is-a and the is-like-a relationships between based and derived classes, and we also saw how upcasting or polymorphism works between based and derived classes themselves. We also were introduced to the concept of managing or coding in a particular different way, about separating the interface, the implementation, and the driver files. And finally, we saw the concept of overloaded functions, where we can have one function doing multiple different instructions depending on the inputs that are sent to that function. And remember, overloaded functions here as a concept is particularly important for how you may want to define your constructors in C++ for your classes, because you may wish to have different implementations of the constructor to allocate different memory or initialize different private member variables upon creation of your class object. Alright, so that's it for today. I know it's a pretty long lecture. It's basically a lot of explanations as to how classes and objects and the concepts work and so forth. But I'm strongly encouraging you guys to actually try out the code in these slides, copy and paste them into your compilers, and compile them, and see how they work, play around with it. Feel free to break the code or mangle it in any form or fashion and see what you get. If you run into any particular problems, feel free to post them on the forum and ask any questions. You're also free, if you want to directly email me any problems, that's perfectly fine as well. If you're free to ask the questions or the comments down below, that's also fine as well. Anyway, you can contact me, perfectly fine. I will respond to you guys in a timely manner. You will also get live sessions where we actually go about doing all of these concepts, and you actually physically see how we go about doing this. But I'm strongly suggesting that you actually do try these yourself, because that's really going to be like the most proper way for you guys to learn through personal experience. Alright, so any final questions before I end today's session? Alright, thank you for that. Okay, so that brings us to the end of today's session. So like I said, if you have any questions, feel free to directly email me, post it on the forums, leave it in a comment down below. And like I said, I'm strongly insisting that you guys try the code out for yourself. Feel free to modify it, mangle it, break it in any form or fashion. If you encounter any particular problems, reach out to me. I'll respond to you guys in a timely manner. So next week, Monday, we're going to be discussing the topic of recursion and dynamic programming in particular. And that's going to be Monday at 1 p.m. Now, there may be a chance, and I'm just saying this, there may be a chance that we may not be on YouTube anymore. We may end up going to Blackboard, but I will let you guys know in advance if that decision is going to be made. But as for now, we're staying on YouTube. If not, I'll post on the forum and let you guys be going. Okay? So until next week, take care, be safe, I will see you guys soon. Later.